the ARC-AGI challenge is a problem set. Problems are unmemorizable, forcing models to use reasoning to solve the problems. Considering that large language models are performing so poorly, it's been said that they are not reasoning at all, and that they are just memorizing. Their good performances on all benchmarks, like the medical and law benchmarks, are just due to memorization alone. But what if I said that the poor performance of these models on ARC-AGI is not actually because of poor reasoning, it's because of poor reasoning specifically on the visual domain? Now, of course, you might say, we can just translate ARC-AGI problems into text. That would solve it, right? Well, no. What I'm talking about is not the way the problem is presented. I'm talking about the reasoning that is required. I'm not talking about whether the problem is put into text or into words. Because if you put it into words, it's going to get translated into tokens. And if you put it into text, it will be translated into tokens as well. So this doesn't matter. The model is indifferent to the modality in a certain sense. What the model isn't indifferent to is the type of reasoning that is challenged. And the type of reasoning that's challenged from the ARC-AGI challenge is specific to the vision modality. And I will showcase this by an example. Just look at this problem. How would you go about solving this problem? Now, it's very easy to see, right? You just need to fill in the surface area of the enclosed spaces. This is not hard reasoning. This is just pattern recognition. We can easily recognize enclosed areas, and we can easily recognize consecutively connected blocks of yellow. Together, we can see that we just need to fill in the surface area. The way we solved this problem was based on visual reasoning skills. Now, these models are so lacking in these visual reasoning skills that they cannot solve ARC-AGI problems. As shown by a paper, they tested large language models on the most famous IQ test there is, and they could easily compare it to humans. And what they found was that models performed very well, except for visual reasoning. They were terrible at it. So considering that they are so bad at visual reasoning, it's not hard to see why they fail so badly at ARC-AGI. These results on, for example, medicine benchmarks are still impressive. And even if we control for contamination, meaning they couldn't have seen the data, they still perform better than doctors. And this shows us that they are capable of some kind of generalization. Maybe not as novel as needed for the ARC-AGI challenge, but considering that our models are poor visual reasoners, we cannot use ARC-AGI to measure their overall reasoning capacity. We would need something else. And it's just going to be a matter of time until models are able to solve these kinds of problems. The visual reasoning will increase. If we look at the models, just over time alone, they already improved on the ARC-AGI challenge. So we can see that they are reasoning on the visual domain and improving. I'll show you now just one more example to convince you that models need to use visual reasoning. This is considered a hard problem. How do you solve this? Well, you see the first input, and then you see that the output has a similar structure of the input, but just smaller in the top left corner. And then if you looked at the first row, it's just that one, repeated 3 times. Then you go to the middle, and you see that it's not matching, it's not the exact same, but the colors are the same. Knowing this, you can just try flipping it, rotating it, and you find out that it fits when you rotate it clockwise, 90 degrees. Now what this shows is that for the first part, where you recognized the input in the output was just pattern recognition. Then for the first row, you did another pattern recognition. And then for the second row, you tried out the first pattern by kind of overlaying the image of the first pattern and then seeing how they differ. You saw that the colors were the same, pattern recognition, and that you might be able to get it through flipping and rotating. By previous experience with these kind of problems, notice how much visual reasoning you just used. Nothing of this is really general. You really need visual reasoning. ARC-AGI is a testament of the model's visual reasoning capabilities and of general reasoning. But we can never see how much general reasoning there is if the model is limited by the visual reasoning.